saved paper 6 by accident and went and fixed it.
Okay guys, I am going to give you a problem right now, just to kind of get your brain going again. Okay, so this is 3 over x minus 4 over 2x minus 1. And I'm going to give you an attack method on it here. You recognize there are two totally different things that need to be integrated. So my suggestion would treat them as two totally different integration problems. Okay, so if you split them up like that, it makes life a little bit easier when you start to assess. So you're going to do 3 over x, assess it from 1 to 3, and then 4 over 2x minus 1, also assess it from 1 to 3, and then combine your terms. Okay, so I'm going to let you work on that for about 2 minutes. I'm going to take roll real quick, and then we will do something new that I started to talk about yesterday as you guys were packing up. Yes, no, maybe, yes, no?
All right.
Okay, all right. Feeling okay? Okay, so
27.
the problem, as we started this problem, I was asked, you know, if I bring the x to the top, remember, if it's x to the first power in my denominator, that's when we need to remember we don't want to bring it to the top, okay? Because that's when it becomes, to the negative x to the 0 over 0, and you can't do that. So this is a classic case of a du over u situation. Not quite du over u, because the 3 can be pulled out, and I'm left with a 1 over x. That is the du over u. So I'm going to have 3, the natural log of the absolute value of x, from 1 to 3. Are we cool? Okay. And then minus, as I showed you yesterday, if I see a fraction, I take the derivative of the denominator in my head. What is the derivative of 2x minus 1? Well, it's 2. Is that what I have on top? No. But if I pull out the 4, and if I pull out the 4, and I need a 2, so if I stick a 2 up there, then I need to pull out 1/2. So does that ring a bell from yesterday at all? And so what we're left with is the natural log of the absolute value of 2x minus 1 from 1 to 3. Yes? So far so good. Okay. So now we're going to assess it with 3 and 1. And why was I able to drop those absolute values? Because they're positive, right? Minus 2, I'm going to put parentheses here, because what's going to happen is minus has to go through the whole thing. So minus 2, the ln, and plug in the 3, so I've got ln of 5, minus 2, and the ln of 2 minus 1, which is 1. All right, how do we feel? Pretty good, yeah. Okay, so 3 ln of 3, not much I can do with it. Ln of 1 is what? 0. So this is 0. Okay, minus 2 ln of 5, not a whole bunch I can do with it. And what's ln of 1 again? Also 0. So that's gone. So what I'm left with is 3 ln of 3, and then minus 2 ln of 5. And as we learned yesterday, we're going to use our properties to the most of our ability here. I know that with natural logs, I can start to put them together if they don't have anything in front of them. So the first thing I want to do is take these and bring them up as exponents. So I have ln of 3 to the third minus ln of 5 to the second. Is everybody following that lead? Okay, so when I have that, then I'm going to be able to say subtraction means to do what?
Divide.
Divide. So ln of 3 to the third, which is what, 27, divided by 5 squared, which is 25, and that's most likely what they're looking for your answer. How do you feel about that? Probably it was a yes, 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 until I'm like, oh shoot, I have to do that part. And most of the time, they're going to say, show that this looks like this. They're going to give you the answer. that they need you to get to. We did one last night from the homework that we were like, ooh, wow, yeah, that's ugly. So, okay, so here's what I'm gonna give you next. I started to hint at it yesterday. So whenever I have a fraction like this, I cannot do du over u here because my exponential powers are the same. So if bigger on top or if the same from numerator and denominator exponentially, then I want to do long division first. I want to divide it out, clean it up as much as possible, and then go ahead and do an integral if that's what the question is asking. So I want to take this and review how to do long division. Just spend a few, so it doesn't hurt to try to do it again. Go ahead.
So do you do the long division anytime you have anything like with a variable in the numerator, or only when they're
Equal or bigger on top.
Okay, so.
So, and I didn't preface it with we are indeed going to do an integral. If I see an integral of something that looks like this, and I see that the exponential powers are the same or bigger on top, I'm going to long divide, no matter what.
Okay.
That's where we start. Okay, so we're going to long divide this. So I'd like you to practice that long division for a second. It's been a few, so it's not going to hurt anybody to review it. All right, is that where we're at so far? Okay, so our remainder is -2, and so that's good. We want to have a remainder, because what's gonna happen here is that we're gonna have,
positive 2?
yes, good catch, thank you. Good save, because I would have done it wrong, right? What's new? So now we have 2, big 2, plus the positive 2 over the divisor. So that's what we have now. So we have 2 plus 2 over 2x minus 1. So if this is the question, so let me show you what the actual question would look like. So let's go ahead and assess this. I want you to show that it's equal to 8 plus the ln of 9. Okay? So if I'm asking you to integrate this from 1 to 5, and I want you to show the answer is 8 plus the ln of 9, which is what they do a lot. They give you the answer. They're like, hey, make it look like this, right? So what you would do first is go look. Wait, there should be an X. There should be an X there. What they do is they go look. They want you to remember that you have exponential powers that are, in this case, equivalent. You want to long divide. So rather than integrating this, you're going to integrate this instead. Does that make sense? Because we have already done the legwork for that. So this becomes this, and we can integrate. So what's the integral of 2?
2x.
Yes. So 2x. Very nice. And what is the integral of 2 over 2x minus 1?
Natural log 2x.
Uh-huh. Did you kind of do it in your head? Like you go, look, the root of this is 2. Oh, good, I have a 2. It's du over u, so it's natural log of. So you kind of do it in your head as you get more comfortable with it. And we're going to assess it from 1 to 5. Okay. Are we cool? So now go ahead and assess it. Let's see how we do on the old-fashioned natural log stuff. This one's actually a really easy one. How do you feel? Yes, yes, decent? Okay, cool. All right, I'll give you one to do. There you have it. Almost done?
Do you always add a 0 to the end?
Say it again.
Do you always add a 0 to the end?
I always add a 0 to the end. There's no regular number, so I put that as like a placeholder. Does that make sense?
No, not really.
Divide it in here. I'm going to get 3x. Feeling good? So that's 6x squared minus 15x. Subtract the whole thing down. That's gone. That becomes a 20x plus 0. Feeling good? 10. That goes in there 10 times. So 20x minus 50. Subtract that down and I get 50. Yes. Yes, yes, yes. Okay. So my new thing that I'm integrating from 0 to 1 is 3x plus 10 and then plus 50 over 2x minus 5. Did that go well? That's a no? All right. Say it, I'm gonna text at the same time as listening. They say don't text and derive, but I'm gonna have to.
Oh my gosh, okay. That was good.
That was good.
Was that caught on video?
It was, wasn't it? Was it caught on video? She's not even listening. Was it caught
No,
on video?
yeah.
Oh, very nice.
I thought you weren't talking.
That's
I thought you said
fun.
Connor for some reason.
No, was it caught on video? Was Connor on video? Connor is not on video, it's me. I'm texting and driving. Oh my gosh, I can't even do it now. Oh. Actually, texting and integrating to be more precise. There.
Stupid fractions.
You know what? You know what I love about you all? Is that you can laugh at that kind of joke. I would say that at my house and it would be like, okay.
Crickets.
So this, I can't have my sense of humor with them people over there. All right, so how does this integration look?
50 halves.
He's doing no good.
It's doing no good. The 50 is a problem. It's kind of like my texting and deriving joke. So I'm gonna bring the 50 out, but I do know if a 50's gone, it's a 1 over that. Derivative of the denominator is a 2. If I plug a 2 in on top, what do I have to pull out?
Half.
The half. So, how do you guys feel about that? Did I go too fast? From 0 to 1? Did I do it wrong?
No, you did it right.
Okay, good, thank you. You guys got silent like they are at my house when I tell a joke.
Oh. Yeah, that part.
Actually, my oldest thinks I'm kind of funny. The rest of them not so much. He says, I like your sense of humor now. All right, so are we good there? Now you're gonna plug in 1 all the way across, and you're gonna plug in 0 all the way across and subtract those answers. Connor, what happened? You look like I made you feel bad.
In the beginning, you say it's equal to 23 over 2 minus 25.
Do you think I wrote it wrong?
Yeah, I just don't know how you get from that to that.
Oh, okay, hold on, okay.
Is it just like-
Yeah, 23 over 2, let's make sure the original problem's right. 6x squared plus 5x over 2x minus 5, so far I'm good. And 23 halves minus 25 and ln of 5, yeah, so let's do it, let's see what happens. I didn't incorrectly write it on the board, so that's good news. So I'm gonna plug in the 1, is it from 0 to 1?
Oh, wait, okay.
Indeed, 0 to 1. Okay, we're just double checking, because we all know. So 3 times 1 squared over 2 plus 10 times 1 plus 25 ln of -3, yes? But it becomes +3. Are you guys feeling it? So 2 minus 5 is -3. Absolute value brings it to a positive. And then minus parenthesis.
No,
Wait,
it's -3. It should be -5.
It's absolute.
2x minus 2 minus 5.
2 times 3 is 6, minus 5 is 1.
Wait, isn't it a 1 I'm plugging in?
Yes.
Oh,
Oh.
I'm plugging 0.
Why
we
did I
cool?
get 3?
Are we good?
Yeah.
I'm not good.
You guys, because 100% it could have been 2 minus 3 and I put 8 up there and you guys would have been like, Miss K. So I think I'm right for a change. We're good. And now I'm going to plug in a 0, so that's 0 plus 0 plus 25 times the ln of -5, which comes out as a 5. Okay, check my math because it went pretty quick, so I'm still trying to text and drive. Can get the fruit and JV meal. See if I don't do it, okay, there we have it. All right, are we good?
Almost.
So we have 3 halves plus 10 minus 25 the ln of 3 minus 25 the ln of 5.
It should be plus the 25 ln of 3.
I have a plus there.
Yeah, you do.
What the heck?
I think your texting is messing you
I
up.
did not, I texted and I dropped, I put it down. I
It's
put
still
the
on your
phone
mind. Still on your mind.
down. I gotta pay for the JV meal. Last week they called me and they're like, are you paying for the food? I was like, yes. And I gotta pay for the varsity meal too. Okay, there's my jobs for the day. Okay, so, are we good? So this here becomes 20 over 2. Are you seeing it now? Yeah. So 3 halves plus 20 over 2. And then I'm going to factor the 25 out. I found that last night. That works out really well. So whatever's in common for that natural log, pull that puppy out. And then you have ln of 3 minus the ln of 5. So here I've got 23 halves. And then the 25 ln of 3/5. Uh-oh. Oh. Yeah. Okay. Uh-huh.
Oh no.
It's right. However, I need it to look like this. So talk to me about what changed here.
The signs
Okay.
and the.
Daniel, can you figure it out?
You could factor out like a negative 25 in there, and then it would be ln of 5 minus ln of 3, which would be 5 over 3.
To the -1, right? So basically, exactly right. So I could say, look, I have a positive here. So if I make this a negative, right, I'm gonna have to change the sign up here. So literally, this takes this and becomes that. Because think about this, -1 times 1 would be that positive that I had. So it's kind of like backwards, right? So there, the exponential power of -1 flips that fraction. So minus 25, the natural log of 5/3. So in the future, if we hit that kind of obstacle, that's not a problem, we can handle that. Knowing that an exponential power of -1 will flip that fraction. Okay? if we wanna make it a positive one. What do you guys think? Yay, no? Feeling good? Not so much about it?
Wait, could you not factor out -25 instead?
We could have factored out -25 from here in the first place.
Okay.
But I was here and I'm like, I gotta fix it now,
Okay.
so that's how I fixed it. But let's see that.
I'm happy I didn't see that.
-25,
Do you see what that is?
and then the ln of 3 plus the ln of 5.
Yeah.
That won't work. That'll make it multiplication. ln of 5 minus ln of 3.
So I'm plugging up, this makes this a negative.
Yeah.
I wonder who did that to him.
Yeah.
Okay.
Yeah.
So then how would we get the negative? Like it's 3. Or would it just already be over?
Wasn't it a positive 25?
Yeah, but then she switched it, and then she had to switch it again, and it didn't play, so it.
They were saying, look, I want -25 pulled out.
But then it becomes a negative ln of 3. So what happens to that negative ln?
Is it just the -1?
So this can be ln of 5 minus the ln of 3.
Isn't this a positive?
Oh yeah. You wrote it that way. You wrote it backwards and I was like, what?
Right, right.
So then she changed.
Okay, I see it now.
Which way do you like better? None?
And pulling the -25 out.
I like the idea that I do a negative here, positive there. So if I negate the sign up here, made that positive, that it flips that fraction. But that's just, I don't know. In my perspective, fun, but not for everybody. Okay, I got another one. And then I want to teach you.
I can't open up this one.
So I think the test on this is Wednesday, not Tuesday.
Okay.
Did you already tell them?
What? No.
Wednesday, because I think I want today, we're gonna do this stuff, I'm gonna teach you, yeah, and we need time to work on the rest, so.
Did you decide for AS level that it was going to be on Wednesday or Tuesday?
It's Wednesday.
Okay.
Yeah. They're all, yeah. So for those of you that are swimming, you're not missing a test day. That's fun, right?
I think I test on Wednesday.
Okay, well,
It should be over. It should be over by.
what test is it?
My retakes for U.S. history.
Oh, I don't know if that's morning or afternoon.
Is that E?
I believe it's
It's an
morning.
E.
Connor, you're taking that too?
Yes.
No, we're talking about retakes for U.S. world history. You decided it? Have you been studying?
Not very much.
Uh-oh.
The curve is like the regular, not the derivative.
Yeah, you're looking for the original curve. So given that the curve passes through the point E and E squared, find the equation of that curve, the original curve.
Yeah, that works.
I'm listening. Did you say question?
X value is, we already have an X value. So we just need to get this. So X equals the line.
Right it, right?
Then that's the L.
So you have y equals Does everybody understand E is just a number?
Yeah.
Did you remember your plus C?
Yes.
Oh, two. I just put X squared, is that,
That's 2.
for that?
Yeah, it's X squared.
Okay.
That should equal E squared.
So it wants the equation of the line, curve, which the way we do that is through using my favorite formula. So you need an X and a Y and a slope. We've got an X and a Y. Oh.
Is that what C is?
Yeah, yeah.
But do you have to find the slope, or could you just use the integral?
You just do that to find C.
Yeah, we're just gonna find C first.
Okay.
And then I think it wants the actual equation.
It doesn't
Oh,
want
you know what? You
tangent.
just have to find C. Never mind. You don't have to find no favorite formula involved.
Because you're just finding.
I just got excited for nothing.
Well, that's okay.
I
You
know.
find C
Tangents.
and then you plug it in to the
Yeah,
Then see.
I tried.
You need to simplify it, this way.
So I do recognize that these cancel, yeah?
Oh, I mean like at the end.
Oh, no.
Oh,
Mm-mm, no. So, do you agree C is equal to negative 3 ln of 2e? Yeah? Is that simplifiable?
It is.
What does multiplication mean with natural logs?
Put the something in front of it. I can't remember.
So like I could do, it just for, you know what, giggles. So we have ln of 2 plus the ln of e. Do you see that or not?
Okay. Why is it, do you have, why is it 3 negative?
There are different ways.
Oh, just because it is. Because I am solving for C, so if I subtract that over, right, I subtract that over, and then I subtract that over. Do you see it or no?
I see it.
Okay,
now.
good.
Okay.
Wait, Miss K,
Yeah,
I brought the 3 as an exponent instead of.
as you can, that's not a problem. I was just having fun with it. I mean, you don't have to have this kind of fun, but, I mean, I was just, that's really, it could clean up to that if you wanted it to. My version of fun. That was only fun for the joke time, that's it. I see how you all are. All right, so are we cool there? So C could be acceptable here, or if you wanted to have fun there. So y is equal to x squared plus 3 ln absolute value of, you gotta keep the absolute value in because you don't know what's gonna be plugged in, right? And then the C could, I'll just do the not so fun one. There. That's sufficient. Yeah, yeah. Okay, sweet. What do you guys think? Good? Okay. Okay, so let me introduce the, well, sine, cosine, tangent. Yeah. Oh my goodness.
They were missing this on the Aice retake yesterday.
They didn't have any of it?
They had like one question, but it was with like 4 points, just one of them. Everything else was awful. Evil.
I wonder who makes those tests up. I don't know.
I do, I actually do.
There was like a geometric like distribution that was worth like 7 points.
Okay, I want you to look at your bright colored sheet of paper for me. Please.
Good.
It's just the reverse of the stuff.
It's just the reverse.
Except there's a marker. Oh, there's a lot of stuff.
You don't say.
On your bright colored sheet of paper, does it give you these? Does it give you at least the cosine, sine, and secant squared?
Yes.
Integration.
It better give us this.
They better.
Sine, cosine, and secant squared.
The reason why they give you those is, what's the derivative of the word sine? The word sine.
Negative cosine.
Just the regular word sine, derivative is
derivative.
positive cosine, right? So what's the integral of cosine?
Negative. Fine.
Let's start fresh again. What's the derivative of the word sine? Cosine. So what's the
Sine.
integral of cosine?
Sine.
Right. The derivative of sine is cosine. The integral of cosine is sine. Okay? So now let's get even deeper into this where you guys are obviously gonna have fun with it. What is the derivative of the word cosine?
Negative sine.
So cosine becomes negative sine, yes?
Mm-hmm.
So then what's the integral of positive sine?
Negative cosine.
Negative cosine.
Whoa.
Now, do you have to have that memorized? I don't think so, because I think it's on your bright colored sheet of paper.
Mm-hmm.
Yes.
Am I correct? Yes? And now, tangent. What is the derivative of tangent? Secant squared. So what is the integral of secant squared?
And
Tangent.
Negative cosine minus 1 something.
Plus C.
Oh, see.
It's just really bad handwriting.
Sorry.
I got excited and did it fast. Okay, now, what do they have going on over there?
That's some special
I
stuff.
don't know, man.
Right, I don't know, man, is right. Okay, so, do me a favor, think about it this way. If I derive the inside of this, right? If I derive the inside of this, what is that? A. And what are we doing when we're deriving like the inside of the 2x plus 1, or we're deriving it? We divide by it, because when we took a derivative, we multiplied by it. So we want to do the opposite, so we divide by it. So the answer to these is 1 over a, and then it's the same thing you see here. Sine of ax plus b. This guy would also be 1 over a, same thing as this, negative cosine of ax plus b, and then last but not least, 1 over a, tan of ax plus b, starting to throw stuff at me, and then all of them have a plus c.
No,
And those are plus c, not 1 and whatever else we think they might be. I know. That's why we're doing the test on Wednesday instead of Tuesday. Because today is Thursday. So,
Tomorrow is Friday. I'm gonna go to the so
what?
I hate church.
You said what?
I hate church.
Oh. Makes me sad. It makes you totally sad, right? All right, let's
I like
practice, and then I'm done for the day.
I'm done for life.
What is the integral of sine of 2x? Think about it this way. What is the integral of the word sine?
Negative cosine.
Negative cosine. We have a 2 in here, okay? So take the derivative of whatever this is, what do we get? 2. So we have to pull out, divide by that number. So this is gonna be 1 over 2 negative cosine of 2x plus c. The 2x remains. The only thing that changes is that when you derive this thing, you divide by it.
It's kind of like chain.
It's kind of like reverse chain rule is what it is.
I don't remember reverse chain rule.
No. Okay, do this one. Take the integral of cosine of 3x. Was that, okay, surprise! All right, so what is the integral of the word cosine?
Sine.
Sine. So we are gonna say, okay, we're gonna start with the basic, leave the 3x intact, take a derivative of it, what do we get?
1/3.
So yeah, you pull out a 1/3. You guys are ahead of me. So. All right.
to,
I think that's good for today.
That's good for today. Thank you.